Hello everyone. Today we are going to read about the X-ray basic concept. And today lecture we are going to read about the introduction of the X-ray, the introduction of the electromagnetic spectrum, and how X-rays are discovered, and two basic concepts of the atomic structure we are going to read about in detail. We are going to introduction, discoveries of X-ray, atomic structure, the two basic concepts that you should know before going towards the actual topic of the X-ray. So these three topics we are going to read today. Now let us start with introduction and discovery, introduction of the electromagnetic spectrum and discoveries of X-rays. So basically the X-rays, itself is a part of the electromagnetic spectrum. X-ray itself is a part of the electromagnetic spectrum. So what is electromagnetic spectrum? Electromagnetic spectrum is a spectrum comprising of the energy components, and those energy components are basically photons. They propagate in the space by the combination of the electric and the magnetic field. So if you look at the increasing order of the frequencies or energies in this spectrum, it includes the lowest frequency and the lowest energy, that is the radio waves, and the energy and the frequency increases as it increases towards the microwave, infrared, visible light, UV rays, X-ray and gamma rays. Here the lowest energy and the frequency is of the radio waves, and the highest energy and frequency is that of the gamma rays. And all the component travel in the space at the speed of light, that is 3 into 10 to the power 8 meter per second. They only differ in the amplitude, wavelength and the frequency. So how the X-rays are discovered? The X-rays were discovered by the Sir Wilhelm Conrad Roentgen on 8 November 1895. So he was the founding father of the radiology, and 8th November is celebrated as International Radiology Day. He was also awarded as the first Nobel Prize in the Physics in 1901. So how he discovered the X-rays and how the name X-ray is given, I'll tell you the small story in detail. So Sir Conrad Roentgen was working in the cathode ray tube that had two electrodes, one positive and one negative. It was filled with a special gas. When he passed the high electric voltage through it, the tube could produce the fluorescent glow. He shielded the tube with heavy black paper and found that green colored fluorescent light could be seen coming from the screen setting a few feet away from the tube. He realized that he had produced the previously unknown invisible light, or the ray, that was being emitted from the tube. A ray that was capable of passing through the heavy paper covering the tube. He realized that. On further experimentation, he also found that the new ray would pass through the most of the substance, causing shadow of a solid object on a pieces of film. He then named the X-rays because in the mathematics, the X-ray was kept to the unknown object or unknown value. So at that time it was not yet discovered, so the unknown rays was named as the X-ray by the Sir Wilhelm Conrad Roentgen. So today also we know almost everything about X-ray till the name X-ray is given. X-ray is given, and this X-ray name is still carried out further to his honor. So likewise the X-ray is named and discovered. So you know about the X-ray basic concept, that is the concept of the electromagnetic spectrum and how the X-ray are discovered. Now you should know the two basic concept in the atomic structure that will help you to learn more things about the X-ray in the further lectures. So let us move towards the atomic structures, and two basic concept you should really know before actually going towards the X-ray topic. So In order to understand the X-ray better, we need to know a few basic concepts about the structure of an atom. We considered a tungsten atom for an example. We take example of the tungsten atom because tungsten filament is used in the every part of this X-ray. So it would be better if you take the basic concept from the tungsten atom. So an atom consists of the central nucleus. Atom consists of the central nucleus comprised of the protons and neutrons. It is the basic science you all know. Electron orbiting around the nucleus in the cell, K, L, M, N, and so forth. Each cell can contain a fixed number of electrons, that is 2, 8, 18, 32, and so forth respectively. When all cells are filled with the entire full set of electrons, the atom is considered as the stable atom. You all know that. I am just revising the basic concept. So let us consider this K cell. This K cell electron in the image, in this image, the K cell in the allosaur, in the K shell, the electron in the K cell, there are 2 electrons in the K cell. If you watch carefully, it is the bound electron, in the sense that it is bounded by the positive charge of the nucleus, and it must stay in the K cell. In fact, all electrons are bounded by the positive charge of the nucleus bound. The outer shell electrons are loosely bound. So in the nucleus it has positive charge, and the electrons have the negative charge. The more nearer to the nucleus, the more tightly it will be bound, and the farther away from the nucleus, it is loosely bound. So what happened? The scientists decided to conduct an experiment and try to remove the innermost shell electron for the tungsten atom. Because it was bounded by the nucleus, when they tried to pull out this electron, they had to spend some energy while pulling out. The energy was precisely 70 kilo equivalent volt. Thus, when they spent the energy of 70 kilo equivalent volt, they pulled out the K cell electron. The following mathematical equation summarize the above equation, which is the X is the initial energy of atom, the 70 kilo equivalent volt. The 70 kilo equivalent volt is equals to free electron in the space that has 0 energy level. So X plus 70 is equal to, X plus 70 is equal to, it is 0. X plus 70 is equal to 0. So X is equal to minus 70. So this X is equal to minus 70 represents the initial energy level of the K cell electron. So it is also the energy level of the K cell electron itself. For example, the energy required to release the electron from this K cell is, if 70 kilo equivalent volt, then it must contain the 70 equivalent volt, because same amount of energy is required to release the electron from the same cell. It is the basic concept. So all electron in the cell are exactly that the energy level, which is in the K cell of the tungsten atom, the energy level of all electron is minus 70. If the amount of energy required to remove K cell electron was 70 kilo equivalent volt, the amount of energy required to remove the L cell electron would be less than that of the K cell. Obviously, it is the further away from the nucleus, so the energy required would be less, and the scientists found that energy is 12 kilo equivalent volt. Similarly, from the M cell, it was further less, it is 2 kilo equivalent volt. So first basic concept: every cell in the atom has its own fixed energy and has level associated with it. All the electrons in the cell lie at that fixed energy level. All energy level for the inner cell in the tungsten atom are: in the K cell it is minus 70 kilo equivalent volt, L cell it is the 12 kilo equivalent volt, M cell it is the 2 kilo equivalent volt. Now look what happens after the removal of the K cell electron. We remove the electron from the K cell. What happened? In the K cell there is just one electron left because of the deficit electron. An electron void or empty space is created in the innermost cell. If you remove the one cell, then empty space is created in this K cell. So it will make the K cell unstable because two electrons are required to fill the K cell. If we remove the one electron, then K cell will have only one electron. K cell will have only one electron. Thus, the K cell will become the unstable. So what happens is that an outer cell electron jumps to the inner cell. From the L cell, one electron will jump into the K cell. Subsequently, the outer electron jumps to the underlying inner cell, and finally free electron in the space fill the outermost cell, making the atom stable again. So let us look at the jumping L cell electron. L cell energy in -12. I already told that. And K cell energy is -70. Thus, if an electron has to jump from the L cell to K cell, it will have to lose some energy so that it comes to an energy at the level of -70. Thus, the energy lost is equal to the energy difference between the cell. Here is the -58 kilo equivalent of energy. So, another basic concept 2. Whenever an electron jumps from the outer cell to inner cell, it has to lose some of its energy. The amount of energy lost is equal to the difference between the energy levels of the two cells. So, K cell energy has -70 kilo equivalent volt. L cell energy has -12 kilo equivalent volt. If the electron jump from L cell to K cell, it will have to release the 58 kilo equivalent volt of energy. So these two concepts will help you to understand the X-ray better. These two concepts you should know thoroughly. So now let us move towards the another topic, that is production of the X-rays. How the X-rays are produced, the mechanism of production of the X-rays.